All right, we got some old people here today. I got Grandpa Griffin down here. Grandpa, what time you got, sonny? Oh my goodness, it's time to start class. All right, well, we'll go ahead and get started here. Got Grandma in the back and another Grandma and Gramps sitting right there, Grandpa Michael. He doesn't see too good at his age, you know. It's geriatric day here at Grace Christian School in celebration of the 100th day, even though this is only the 99th math lesson, but my mind wanders. I think, if I read correctly here, you had to do page 126, numbers 7 to 35 for homework. Page 126, numbers 7 to 35, so have your books open. Oh, I need to borrow that cane. Page 126, numbers 7 to 35. Oh, good job, Sonny. Have you visited with us before? You look familiar. My, you're a tall lad, aren't you? All right, good. It's good. Oh, Grandpa Michael.
I was blind, but I still did it.
Oh, now, I didn't ask you to do 1 through 6, my, but you're a precocious child. Excellent, Sonny. Oh, Grandma, good to see you. You did a good job. And Grandma Jalen, you did well also. It's pretty good. Oh, always good to have visitors here at the nursing home. Very good. All right, well, let's see how we did on the homework here. Number 7, you were supposed to fill in the blanks and identify the property used. You, Sonny, you visited with us before. What did you put in the blank for number 7? 5 is correct. And what property is that? That word you said. My dentures don't let me talk like I used to. Number 8. There's 2 blanks. You, the pretty little one over there. What goes in the blanks?
2 and 2.
2 and 2. Very good. And what property was that, Missy? Distributive property. Good. And number 9, what goes in the blank there? A little guy with the glasses.
That's my grandson.
That's your grandson? Oh, he looks just like you. Okay, I don't think I can keep this up any longer. All right, Corey, what did you get for, what goes in the blank on number 9?
8.
8, and that was the... Well, we didn't distribute anything. Remember, distributive has to do with, we've got a group of something and we multiply by everything in the group. All we did was flip-flop the order.
Associative.
Associative is when we change a grouping, we're flip-flopping. Which one's where you change order? Commutative, or change location, right? Commuting from one place to another, you're changing location. Number 10, what goes in the blank? Grandma.
What was that?
I said number 10, Grandma. What did you put in the blank?
Number 10?
Yes.
9.
9. No, not 9. 10. What did you put in the blank for number 10?
I put 9 in the blank.
Oh, 9 in the blank for number 10. Yes, that is correct. And what property is that? What property is that? Turn your hearing aids on, Grandma. Associative property is correct. Yeah, my dentures worked that time. All right.
I'm surprised mine did.
Number 11. What do we put in the blank? Equal or not equal? Michael?
Equal.
Equal sign, because that is? Commutative. Number 12. Equal or not equal? Griffin?
Not equal.
Not equal. 0 does not equal 10, because what property did they mess up?
Associative.
They tried to use the associative, but subtraction is not associative. Number 13, what goes in the blank, Ben?
Equal.
Equal. Wait, you're the young whippersnapper who's visiting the home today. You didn't dress up. You're not a grandpa today. You can answer in your usual youthful voice. So equal, because what property for 13?
Equal.
Yeah, because what property was applied?
Look at number 13. What property is that? 2 plus 7, 7 plus 2. They flipped the order. They changed locations.
Composition.
Not composition.
Commutative.
Commutative. Number 14. Equal or not equal. Kirsten.
Equal.
Equal because that is the
Associative.
associative property being illustrated. Number 15. Equal or not equal.
Equal.
Equal because that is the commutative. They did not change what was grouped. They just changed the order in the groupings. That's commutative again. And then number 16. Grandma.
Not equal.
Not equal, you're right. And why isn't it equal?
It doesn't add up correctly.
Well, it doesn't. -2 and +2 aren't the same thing, but what property were they trying to use and they didn't do a very good job? You can't trust young people today, can you? Well,
Commutative.
they tried to use the commutative property. Subtraction's not commutative. They should have known better. Back in my day, we knew better. I remember when I was in the war.
Anyway.
School was torture.
All right, number 17.
We had to walk to school in my day, you know.
Up both
My
ways.
day too.
All right, number 17. We're working with signed numbers. Let's go rapid fire here. Number 17, Elaine.
13.
13. Number 18, Joel.
-5.
Oh,
Oh wait, no, -6.
-6. Number 19, Kirsten.
-8.
-8. Number 20, Ben.
5.
Keep the sign of the greater. The -9 is greater absolute
-5.
value, so -5. How about number 21, Ben? Back to you.
-2.
-2. Good. Number 22, Griffin.
-2.
-2. Number 23, Michael.
-4.
-4 is correct.
Number 24, Jalen.
I'm lost.
We're on number 24. What was your answer?
Oh. 5.
+5. I went a little too quick for Grandma. Number 25, Corey.
12.
+12 when we add the inverse. Number 26, Luciana.
0.
0. They are additive inverses once you add the inverse. Number 27, Bryson.
13.
Keep the sign of the greater.
Oh, yeah.
Negative wins that time, -13. Let me stay with Bryson on number 28.
-35.
-35, add and keep the sign. Number 29, Elaine.
2.
2. Number 30, Joel.
6.
You're not dressed as an old man.
Yeah.
You're a young whippersnapper who's visiting the nursing home today. +6 is correct. Number 31, Kirsten.
-6.
-6. Now, number 32 to 35, we've got multiple add-ins. Some positive, some negative. Number 32, Ben, just add the two negatives we get. Not asking for your answer yet. Just add the two negatives, we get
8.
-8. Careful, keep the sign. When we add the two positives, 9 and 13, we get
22.
and then we take the +22 and the -8, add those, well, subtract, keep the sign of the greater to get
14.
+14. Number 33, we can't work with it that way, Griffin. We've got to change that second thing, instead of minus and -2, to a
Plus a positive.
plus a +2. So the 6 and the 2 and the 7 are all positive. Those all add together to get what positive sum?
On 28. Oh wait. I'm trying to think. Where's my
On number
math?
33, we got a 6. We have now a +2 because we added the inverse, and we've got a +7. What does that add up to?
Did my math wrong?
Well, let's do it correctly now. So, what's 6 plus 2?
Wait, so would be 15.
15. There we go. 6 plus 2 plus 7 is 15. So we've got a +15, and then there's only one negative. That's -20. We put those together, we get
Subtract
to get
5.
keep sign of the greater.
-5.
-5. Let me show it on the board. I think that might help. So we have a 6 minus -2, and then it said plus -20, +7. So you said we're going to add the inverse, make that a positive. So this is positive, this is positive, this is positive. We said that all adds together to give a +15. The only negative we have is right here, that's -20. If we add those together, or subtract, keep the sign of the greater, we get the -5. Does that make sense? Let me have you help me with the next one as well. Number 34. Again, it says a subtraction is supposed to be in there, but we don't do that. So, Griffin, we've got a 45 plus -8. I'm not going to even write minus -31.
Plus positive 31.
And then a +4. So I've got 1, 2, 3 positives. Remember, this is understood positive. That's a lot of positives to add together. 35 or 45, 31, and 4. How much does that add up to?
80.
Positive 80. And once again, there's only one lonely little negative, and that's this negative 8. So our answer should be
72.
positive 72. And then number 35, Michael, there aren't any subtractions this time. They're all additions, but I've got to add 3 negatives together. Do we all see, class? I've got a negative 29. I've got a negative 16 a little bit later on. And then there is also, I told you, look at that as a negative 4. That's a lot of negative, Michael.
49.
Negative 49. And then there's only one lonely positive this time, and that's the positive 9. Subtract, keep the sign of the greater. Our answer should have been
Negative 40.
negative 40. Questions on the homework. Was anyone perfect on all of them? Wow, a few of you. How many maybe just missed 1 or 2? I said, how many just missed 1 or 2 of the homework problems? All right, hearing problems, yes. Okay, questions. Questions on the homework. Any questions on the 1 or 2 we missed, or if we missed several, do we need to see them worked out? Any questions at all? Going on? Going. Yes, sir. Never mind. Let's take a look at numbers 1 through 6, just above numbers 7 through 12. Question number 1 says, when adding 2 numbers having the same sign, what is the sign of the answer? When adding 2 numbers that have the same sign, what's the sign of the answer? Jalen?
You have to speak up.
Just answer the question. Or we're going to go way over today.
Positive.
Not necessarily.
Wait. Sign of winner. No.
But they have the same sign. So if you add the same signs,
The sign that they have.
the sign they have, you're just going to keep the same sign, right? Keep the sign you were given. All right, number 2, when adding 2 numbers with different signs, what's the sign of the answer? Redemption here, Jalen. When adding 2 numbers with different signs, what's the sign of the answer?
The answer is the sign of the winner.
The sign of the winner. Good. The sign of the greater absolute value, but the sign of the winner is an easier way to say it. Number 3, what is the first step to combining more than 2 signed numbers? This is what we were doing just a moment ago. You got multiple addends. What we got to do? Corey, what's that first step? Which ones? Lucy, you got to help them. We got lots of different add-ins we're adding together. They're all different signs, right? Some positive, some negative. What do we do first?
So add like all the positives.
Good. Get all the positives together.
And then the negatives.
Add all the negatives together.
And then subtract.
Right. But since it just said the first step is find the sum of all the positives and the sum of all the negatives. That's your first step. Number 4, when multiplying or dividing 2 side numbers that have the same sign. What's the sign of the answer? Let's go back to Corey. Multiplying or dividing 2 side numbers that have the same sign. What's the sign of the answer? It's automatically positive. Good. What about number 5? Multiplying or dividing 2 side numbers having different signs. What's the sign of the answer? Bryson? Automatically negative. And number 6, we began looking at this yesterday. What's the name for an ordered list of numbers that follows a pattern? Kirsten?
A sequence.
A sequence. And we're going to pick up with sequences here in just a moment. Sequence. Ordered list of numbers that follows a pattern. Go to the top of the page, though, and I want you to do numbers 13 through 23 at the top of the page. So before we get back into sequences, do 13 to 23 there at the top of page 126. Pencil down pencil down and stand once you're finished. Pencil down and stand once you're finished. Now, I don't know, the 100th day of school, I give 100 grand to the first one done with all the right answers. finished. Keep working, because she might have missed one.
She says, I've been doing math problems for 50 years. I don't miss any anymore. Hit you with my cane if you say it again.
I'm surprised you were able to get up there, Grandma. Good job. Grandma was surprisingly spry.
I got to move back out.
Yeah. We'll go see the doctor in a little bit. Get you your medicine.
Just work bad. Try to ignore the old people in the room and just get your work done.
That is very offensive, young man. Oh, please, honey.
Hey, Joel.
Oh, Corey didn't quite make it out. There we go. You made it out of the chair. Right.
Black older than me.
All right, for sake of time, have a seat. Have a seat. And the first one finished was Elaine. So Elaine, you get first crack at the 100 grand. What did you get for number 13? Everyone else checking your answers.
54.
Say what?
Negative 54.
Now? Let me see. Don't go changing your answer now. Okay, she did write negative 54, and that's the right answer. Okay, go ahead, Grandma. Number 14. 10 is correct. Number 15.
Negative 28.
Negative 28. That's a good job on the top row, Grandma. Number 16, what did you get?
20.
Positive 20, yes. Number 17.
Negative 7.
Negative 7 is correct. Yes, number 18.
8.
Positive 8. Good job, Grandma. Number 19.
Negative 3.
Oh, you may be old, but you still got it where it counts, Grandma. Upstairs, there's no bats in your belfry. Number 20, what did you get?
70.
Say?
70.
Oh, no, it's not 70, I'm afraid. Let's see, her second was the other Grandma in the back. Are you good so far, Grandma?
Yes, sir.
You could hear all those answers?
Yes.
Okay, what did you get for number 20?
Negative 7.
Negative 70, there we go. 3 negatives, you see, an odd number makes it negative. I know, sometimes our mind just wanders. Number 21, Grandma Jalen.
Positive 96.
Is that what you wrote? It sounded like you started to say negative 96. I don't know that I trust you. Okay, you did have positive 96. Give me a second. Okay, number 22, order of operations. What did you get? For letter A.
I gotta find it. Negative 3 2/3.
Oh dear, I'm not sure what happened there. Grandpa Michael, are you good so far?
You got it.
You got it?
Okay, I'm good.
You're good. What did you get for 22A?
3.
3 is correct. How about letter B?
30.
30 is correct. And number 23.
Do you want me to say
Just
what?
the answer is all I need.
100.
100. Though we'd really rather add the 16 and 34 to get 50, and the 29 and 21 to get 50, and here's 100 grand for your 100. All right, anyone else get them all correct, just not as fast as Michael? Anyone else get them all right, but not as fast as Michael? All right, are there any questions on any of those, 13 to 23? Any we need to see worked out? All right, let's review then, as we flip back to page 123, an ordered list of numbers that follows a pattern, class, is called a sequence. Okay, so if we've got a list of numbers, they all, one number after another, and they follow a pattern, it's called a sequence. You don't have to know this, by the way, but the rule that they follow, whatever that is called the algorithm. Algorithm is just the rule that they follow. And we talked about 2 different types of sequences yesterday. One we actually worked with, the other I said we're going to work with today. The first sequence that we worked with yesterday, class, we had some number to start, and then we just add the same thing over and over again. So maybe the algorithm was always add a positive 5. And you just kept adding positive 5s over and over again. Or maybe the algorithm was add a negative 2 over and over and over again. If you're adding something constantly,
then you have what type of sequence, class?
Arithmetic.
Not arithmetic, arithmetic. Say that with me. Arithmetic. Again, arithmetic. So we have what kind of sequence, class, if you add the same thing over and over again? Arithmetic sequence. Okay, an arithmetic sequence. What do we call the thing, the number that keeps getting added? For instance, the 5 or the -2 or whatever it happens to be. What the number that keeps getting added over and over again. Kirsten?
The common difference.
Common difference. Class, what do we call the number that keeps getting added over and over again?
Common difference.
Common difference. We also talked about, we haven't looked at them yet, we're going to go over this today, a sequence in which you keep multiplying the same thing over and over again. So you start with something and maybe multiply by 4, then multiply that by 4, then multiply that by 4, multiply that by 4. It's going to get big really quick, isn't it? And a sequence like that, in which you multiply the same number over and over again, is called, class, a geometric sequence. Okay, so class, say that with me. Geometric sequence. And that's if you multiply. Arithmetic sequence, class, you add a common difference. The geometric sequence is one in which you multiply something called the, does anyone remember? We didn't really work with it much. Common ratio. Class, say that with me. Common ratio. Okay, so arithmetic sequence. There's a puff of powder from your hair, Grandma. Patting her head is a cloud forming. Yeah, there were clouds in my house today as we powdered Chloe's hair and then Timothy's hair and then my hair. Clouds everywhere. And then Renee's like, I don't want powder in my hair. So Renee just came as an ordinary visitor to the nursing home today. Yes?
You powder your hair?
I find that offensive, Jalen. Oh, you powdered it? It looks just as gray as always, Mr. Nadaski. Guess who's going to be running laps today?
Oh! More than you.
Anyway, you'll hobble laps today. Okay. Anyway, where were we? Before I saw this cloud over Elaine's head. It wasn't this kind of glory either. It's just this cloud of baby powder. Yes, geometric sequence. Okay, so arithmetic sequence, class, we add something called the common difference. The geometric sequence, class, we multiply something called a common ratio. Here on page 123, we looked at the arithmetic sequence last time. Let's look at the geometric sequence this time. And look at the first little example that they have there on example 3.6c. They say that their first term of their sequence is 2. And the common ratio is 2. That means, class, we have to multiply 2 times 2 to get 4. So that's my next number. Then I have to multiply the 4 by 2 again to get 8. And then I have to multiply 8 by 2 again to get 16. And so their first 4 terms are 2, 4, 8, 16. Does that make sense?
Yes.
But look at the next one. Their first term is a -5. And their common ratio is also -5. So notice when they multiply -5, the first term, by that common ratio, class, they got +25. But then if they multiply that +25 by -5, following along with me there in your book, notice, class, they now have -125. And then multiply that -125 times -5, in class, they now have +625. Notice, look at the terms. -5, 25. -125, 625. It's what we call an alternating sequence. You don't have to know that term yet. You'll learn that term later. But why does it alternate? Because you're multiplying by a negative. And it keeps changing the sign every other number. So you could get an alternating sequence if you happen to have a negative. With an arithmetic sequence, a negative common difference just makes the numbers get smaller, right? So you go from 10 to 8 to 6 to 4 to 2 to 0 to -2 to -4 with a -2 common difference. But if you multiply by a -2 common ratio, it makes the numbers bounce back and forth between positive, negative, positive, negative. You could also multiply by a fraction, right? It will make it look like you're dividing something. For instance, look at the next example. On the next page, they have an 81. Then it drops all the way down to a 27. Then it drops down to a 9. Then it drops down to a 3. What does it look like we're doing, class?
Multiplying by a -3.
No?
Multiplying by a 3.
81, well, that's what we are doing. What does it look like we're doing? Go from 27 to 9, you would normally say do what, class? Divide by 3. To go from 9 to 3, again, divide by 3. But A geometric sequence always involves what? Multiplication. Arithmetic sequence? Add. Geometric sequence? Multiply. We don't divide. So if it looks like feet down we're dividing by 3, we're really multiplying by the reciprocal, right? So instead of 3, 1/3. Does that make sense? So if I had something like 124, what does it look like I'm dividing by, class? It looks like I'm dividing by 5. Really what I'm doing, class, is I'm multiplying by 1/5 times 1/5. Well, what if I multiply 4 times 1/5? What's that, class? 4 times 1/5. 4/5. And what if I multiply that by 1/5? What's that?
4/25.
4/25. Right? And we just keep multiplying by 1/5 over and over again. Again, that makes the geometric sequence values get smaller and smaller when you have a fraction for your common ratio. So again, you can have a fraction, you can have a negative, it all just depends. Look at page 125 now. Page 125. And number 13. Page 125, number 13. Ben, it tells us the first term of our sequence is 2. And our common ratio is 3. Now the common ratio, class, is the number that you keep multiplying. If it has a common difference, class, that's a number that you keep adding. But a common ratio is a number that you multiply. So if the common ratio is 3, then what's the next term? Times 3, we get?
That 9.
2 times 3, Ben?
6.
6. And then the next term we multiply by 3 again. Well, what's 6 times 3?
18.
And then we multiply that by 3, anyone?
54.
That wasn't on our times tables as kids, was it? And then the sequence just keeps going and going. The number's going to get really big really quick. What would the next number be? Anybody? Times 3? 162. Good, right? And then the next number is going to be up in around the 400s, right? 486. And then after that, you're going to be in the thousands at that point, right? Geometric sequences get very big very quickly or very small very quickly, depending on the thing you're using there. Look at number 16. Right below number 13, we've got a first term of -8, but the common ratio is -1/2. Well, what do you get if you multiply -8 times -1/2? Corey? Careful, negative times negative, signs are the same. +4. And you multiply that by -1/2, and what are you going to get, Corey?
-2.
And you multiply that by -1/2, what are you going to get? +1. It's just going to keep getting smaller and smaller, but also notice it bounces back and forth between negative and positive. It alternates. Questions on how to work with a geometric sequence. Do numbers 14, 15, 17, 18. 14, 15, 17, and 18.
I feel that.
Me too. Right in the quads. Excuse me, hamstrings. Quads are in the front, hamstrings in the back. Yeah. Hold a hammy. So we multiply it by 2. What is negative 1 times 2? 2. No, keep, signs are different. Now we multiply that by 2. Multiply by 2. Multiply that by 2. Now multiply that by 2. That's what we're doing. You start with the first term and you multiply by that over and over again. That's what we just said. You've got to pay attention and follow along with me. Don't tune me out. I admit there's a lot more distractions today than usual, I'll give you that, but you've got to discipline yourself to pay attention. All right, for sake of time, pencils down. Even if you're not finished with all of these yet, let's take a look at these together. Number 14, they already tell me how to start the sequence. Griffin, start with a
-1.
-1. Okay, I've got 3 more terms I have to fill in, and of course it's just going to be a dot, dot, dot after that. How do I figure out the next term in the sequence, Griffin?
By multiplying the +2 by the -1.
Good, multiply by +2, because that's the common ratio. So if I multiply by 2, I get,
-2.
and then multiply that by 2.
+4.
Careful, still signs are still different.
-4.
And then multiply that by 2.
-8.
-8. There we go. If we kept going, of course, we have -16, -32, and so forth. How many have those first 4 terms on number 14? Look at the next one, number 15. It tells me to start off with what term, Bryson? 1. And then I'm going to keep multiplying by what in this sequence, Bryson? I'm going to keep multiplying by a -6. Okay, so that's my common ratio. Well, 1 times -6.
Or -6.
-6. -6 times -6.
36.
Positive 36, or just 36. Ooh, positive 36 times -6.
-260.
-216. How many have those first 4 values for number 15? Questions on 15. Careful with those negative signs. Dropping down to number 17, it tells me to start out with what term here? Joel? 256. And then we're going to get the next 3 terms of the sequence, and it says the common ratio that I'm going to multiply by is 1/4. Now, to be honest, class, multiplying by 1/4 might be a little bit annoying. An easier way to think of it is we can actually think divide by 4. So technically we're multiplying by 1/4, but I can think divide it by 4. Where, Joel, when you divide 256 by 4, you're going to get
64.
And then if we divide that by 4,
16.
and if we divide that by 4,
4.
and if we divide that by 4, the next number would have been,
0.
careful, 4 divided by 4,
1.
1, there you go. But they only asked for the first 4 terms, so we didn't get as far as the 1, which would have been the 5th term. How many got those 3 following values, the 64, 16, and 4, to follow the 256? And the last one we had here starts us off with a 54, and the common ratio here was, class?
1/3.
So we're going to multiply by -1/3. Now again, rather than thinking multiply by -1/3, we might think a little bit easier, Kirsten.
By dividing by 3.
Well,
Negative.
divide by -3. So if we divide a 54 by a -3,
Give -18.
and then divide that by -3,
Positive 6.
and divide that by -3,
-2.
now again, technically we are multiplying by -1/3, right? Multiplying by the reciprocal, division, they're the same thing. It's just an easier way to think of it when they give you a fraction like that. Did anyone go 4 for 4 on these? I know it's a tall ask, but I'm just curious. Wow, anyone get 3 out of 4? How many got half of them right? You got 2 out of 4, okay? Questions on those? Look at the next section there, number 19. They start us off with some numbers. They say 3, 6, 12, 24, 24. And then they want us to write the next number. You've got to look at it and figure out what is the pattern here? What is the rule or the algorithm that these numbers follow? Michael?
Each number's getting multiplied by 2.
You just keep multiplying by 2. Well, in that case then, Michael, what's the next number on for 19?
would be 48.
48 would be the next number. How many were thinking the same thing Michael said? Times 2 gives you a 48. Look at the next one, number 20. They start us off with a 192, drop to a 48, drop to a 12, drop to a 3, and then we've got to go to the next thing. Well, strategy tip, folks. Mathematicians are lazy, and old mathematicians are even lazier, okay? So, I don't want to mess with the big numbers. Are you nuts? No. 48 to 12, or 12 to 3. Those are easy, right? What do I do to go from a 12 to a 3, class? Divide by 4. Same thing for going 48 to 12, right? Divide by 4. But technically, you're not dividing by 4. Technically, class, you are multiplying by...
1/4.
There's no negative here, right?
1/4.
Just multiplying by 1/4. So, if I want to think of divide this by 4, or if I want to think of times 1/4, either way, 3 times a 4th, or 3 divided by 4, class, is
3/4.
3/4. How many were already thinking that before I said it? Do we see how to think through it for those who maybe weren't? Questions on that? Finish the exercise. Go 21 to 24 now. Finish out 21 to 24. We're not going to get into a lot of application with these yet, just kind of introducing the idea to you. You'll see it again next year, a little more depth, and then later on in algebra, you'll learn how we can actually apply these sequences. But for now, just kind of introducing you to them, giving you practice working with positive and negative numbers as well. Yes.
For like geometric sequences, do we reduce if we have improper fraction?
We can just leave it improper. Yeah, they did. Obviously, you see there, they left that. Michael's question was on number 24, they left us 7 halves instead of changing it to 3.5. That's because it's just easier to work with that way. So you can also leave improper fractions. When you actually get to algebra in 9th grade, everything's improper fractions because we're too lazy to fix them. So, junior high, we're still kind of in that stuck having to fix stuff. Things get lazier the further up you go.
Will you check my answers?
Well, we're going to go over them in just a second, Grandma.
Oh, yeah.
Yes, ma'am.
You was on number 24.
But give it your best shot. I think you'll figure it out. You're still pretty bright for an old lady.
What is happening?
What'd you say, Grandma?
What is happening?
I don't know. You're in an old folks' home. What did you expect?
Don't leave this nursery home.
I'm too old to be in jail.
All right, on that note, number 21. 243, 81, 27, 9. Elaine, what does it look like we're doing?
Dividing by 3?
It looks like we're dividing by 3, but we know we don't divide in a geometric sequence. We're actually multiplying by.
3?
It looks like we're dividing by 3, but we know we're really multiplying by a reciprocal.
3 over 1?
This is 3 over 1. How about 1/3? Now, again, if you practically want to just say, I'm just going to divide another 3, that's fine. What is the number in the blank, Elaine?
3.
It's a 3 in the blank, because we can still think of dividing by 3, but technically we're multiplying by 1/3. So, if on a quiz or test, the question asked, what is the common ratio? You would not say 3, you would say 1/3. Does that make sense? Questions on how many had 3 in the blank? How many realized it was a 1/3 common ratio? Let's go to number 22. We've got a negative 48, then a negative 24, then a negative 12, then a negative 6. What does it look like we keep doing, Joel?
Dividing 2.
It looks like we keep dividing a 2. And if you want to keep that thought, that's fine. What would be the next number then, Joel?
Negative 2.
-3. But technically, we're not dividing by 2. We're multiplying class by 1/2, the reciprocal of 2. Yes. Oh, look at the next one. We go from 1/5 to a 1 to a 5 to a 25. What does it look like we're doing, Kirsten?
Multiplying by 5.
We're multiplying by a 5. And so we multiply by 5 and we get
125.
125. So therefore, class, our common ratio must be 5. It really is 5 this time because it didn't look like we were dividing. If it looks like you're dividing, you're really multiplying by the reciprocal. If it looks like you're multiplying, you are. Okay, because we're actually multiplying. The last one's kind of fun. We go from a 28 to a 14, then a 14 to a 7. Just stop there because I don't like fractions. What does it look like we're doing then?
For number 7, for
24. We go from 28 to 14. Then we go from 14 to 7. How do we do those things? We...
divide 7.
No, we're not dividing 7, because 28 divided by 7 would be 4. 28 divided by what would give
The
14?
reciprocal.
No, 28 divided by what gives 14, Ben?
14.
Well, 28 minus 14 gives 14. Help in class?
2.
Dividing by 2, right? It looks like we're taking the 28 and we're saying divide that by 2 to get 14. And then the easier way to look at it is from 14 to 7. It looks like we're dividing another 2 to get 7. Well, are we really dividing a 2 class?
No.
You don't divide in a geometric sequence class. In a geometric sequence, you are always, stay with me, multiplying. So if it looks like we're dividing 2 class, we're actually multiplying by 1/2. But you could think divided by 2. You could think divided by 2, but then it's going to be easier to think times a half. 7 times a half class, 7 halves, and it's right there in your book. Then it's also going to be easier again to think, okay, times another half, and what goes in the blank, anyone? 7/4 in that blank. No homework this evening in honor of the 100th day of school. Have a wonderful rest of your day. You are dismissed.